Hello, Legacy Savers, Marsh here. So today we're going to talk about geometric sequences. So this is kind of like the arithmetic sequences, but just a different kind, a special kind of sequence that we'll see. So a geometric sequence, just kind of like an arithmetic, is a sequence of numbers such that the change between the consecutive terms is a constant ratio, aka we are multiplying by a constant amount, okay? Couldn't spell multiplying for a moment there. So multiplying by a constant amount each time. The common ratio is, again, just the constant change between terms, denoted by R in the formula that I'm going to be giving you here momentarily. So first thing, let's see if we can figure out if things are geometric or not. So again, I'm going to look. Well, 10... What am I multiplying by? Well, 10 divided by 4 is how I can find the ratio. That is 5 halves, so 2.5. I'm multiplying by 2.5 here. Is 10 to 18 the same thing? So 18 divided by 10. That is 9/5, which would be 1 4/5, 1.8. That's definitely not geometric. It's not a constant term. It has to be constantly multiplying by the same value each time. Let's try this one. 625 to 125. So what I'm going to do is 125 divided by 625. I'm going to change it to a fraction. Ooh, 1/5. That makes sense because we're shrinking. So multiplying by a fifth there. What is 25 divided by 125? Ooh, also 1/5. Which would make sense because that's a fifth and that's a fifth. So we're multiplying by 1/5 each time. So this is, in fact, definitely a geometric sequence that we are working with here. Now, the rule for a geometric sequence, kind of like how we have a rule for an arithmetic sequence, it is a sub n equals a sub 1 times the common ratio to the n minus 1 power. Now, there is another way. If you don't want to have to memorize this formula, you can first find the common ratio. Okay? And then what you can do is find the 0th term. So they're always going to give you the first term. If you back up one, then now find your initial amount, kind of like how when we were writing exponential equations, because that's all these are, right? They're exponential equations. So if you find the 0th term, you can be able to write it so you don't have that n minus 1 business in the exponent. It's up to you. It depends on what you want to accomplish and how you want to write it. I'm going to show you both manners for a little bit. One of them is going to be used a little bit more, and actually it's going to be the formula this time. So I want to write a rule for the nth term of the geometric sequence. Then I want to find the 12th term in the sequence. So first of all, the formula. So a sub n, well, my common ratio is times 5, right? And my first term is 4. So it's going to be 4 times 5 to the n minus 1. I know, not terrible. Then they want me to plug in 12. And I cannot simplify that. Do not multiply that 4 and that 5. That 5 is not a 5. He has exponents. So if I plug 12 in, so they want a sub 12, 4 times, well, that would be 5 to the 11th, right? So 4 times 5 to the 11th power. Holy buckets. It is. Can't even tell you how big this number is. 195,312,500. That definitely is the answer. I know, ridiculous, right? But geometric grows really fast. So what if I did the other way? I still have my common ratio of 5 to the n. Now, this is the first term. I need to think what would be the 0th term, the y-intercept, what have you. So if I'm multiplying by 5, I've got to divide by 5. So this would be technically multiplied by 4/5 on it, which if I plug 12 in, I get the same exact answer. So, depends on which one you want to see. This one's going to cause a little bit more fractions, so be aware of that, but one less formula to memorize. Kind of depends. All right, so this one, it's asking me to find the nth term, so I got to write the rule, and then I'm going to find the 8th term. So first of all, I'm going to find the common ratio here. So I'm going to go 2 divided by 5, that is 2/5. I'm multiplying by 2/5 right there. That doesn't simplify. Is 0.8 divided by 2, is that 2/5? Well, yeah, that's 2/5 as well. It's 0.4, which is the same as 2/5. So I'm multiplying by 2/5. That's my common ratio. So again, I'm going to write my formula using I'm going to write my rule using the formula. So first term is 5 times my common ratio, which is 2/5 to the n minus 1. Then ask me to do the 8th term. So that's me plugging in 8 here. So a sub 8 is 5 times 2/5 to the 7th power. So 5 times 2/5 to the 7th power on my calculator gives me an answer of really tiny number here. 0.0082, basically, if I round to 4 decimal places. Let's do the same thing, but with our formula maker now. So a sub n equals, well, my common ratio again is 2/5, right? The only thing is I have to back her up one more term. So if I'm multiplying by 2/5 each time, I'm technically going to divide by 2/5. So I'm going to go 5 divided by 2/5, which is the same as 5 times 5/2. So 25 had 2, 25 over 2 be my answer. And if I plug in 8, I will get the same answer as I just did on the left-hand side. Now, let's say I don't give you consecutive terms. Now, we need to find the rule for the nth term using that I know that a sub 3 is negative 48 and a sub 6 is 3072. Well, let's plug in what we know using the formula that we were recently given. So I know it's that formula, right? So a sub n, well, a sub 3 is negative 48. So I know negative 48 is equal to, I don't know a sub 1, and I don't know my ratio, but I know n in this case is 2, right? So over here, I have negative 48 equals a sub 1, r to the first. Oh, 3. Wow, Marsh. That's a 2 over there. Okay, let's plug this one in. So 3072 is equal to a sub 1, r to the 6 minus 1. So 3072 is a sub 1, r to the 5th. I have 2 equations and 2 unknowns. What if I solved one of them and plugged it into the other, like substitution? Because this is just polynomial. I could do substitution. So let's say I solve this one for a sub 1. Then I can plug it in here. I'll just have r's. That'd be nice. So I'm going to go a sub 1. Well, that's just negative 48 over r squared, right? Just divide by r squared. That's a sub 1. I'm going to take this and I'm going to whoop, 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 plug it in over here. So 3072 is equal to negative 48 over r squared times r to the 5th. Well, these can just kind of simplify, right? Because this is technically on top. So I'll cancel out. I'll get r cubed. So I know 3072 is equal to negative 48 r cubed. Let's divide by negative 48, shall we? Well, that's negative 64. R cubed. I got cube root both sides, it looks like. So negative 64 to the cube root of that, negative 1/3 power. I get that r is negative 4. So my common ratio is negative 4. Well, I can start kind of writing my formula now then, right? So a sub n is equal to, well, it's negative 4 to the n minus 1 power. I don't know the first term, though, do I? How can I find that? What can I do? Well, I can just plug it back in, can't I? I can just plug it in here. Well, I know negative 48 over, well, negative 4 squared, 16. So what is negative 48 over 16? Negative 3. So my first term is negative 3. I know, system of equations, that's back from like first quarter of the year. It's like a full circle happening here. So this would be my formula for these two things. And if you plug those in, you will in fact get the same answer. I know, pretty cool, right? And that is the end of this video. I will see you later, Savers.